Sorry, there was a small problem with respect to the camera, so that I just now fixed it. I there is a I fixed the problem, and now continuation from there. And that also we have seen what applications and general principle. And general principle, we generated molecular ions, what are the fragments ions, okay, what electron volts that we have to give. Okay, 80% of the maximum organic molecules, so they will be producing molecular ion at up to 7 to 15 electron volts. This all we have seen. Okay, this we all have seen this. Now what we are going to learn here further is, in this class, types of electrons. Okay, in an organic compound, in an organic chemistry, there are so many compounds. Okay, and the compounds have always types of electrons, like types of electrons, types types of electrons, types of electrons. What is types of electrons? Sir, we have seen electrons, but I mean we know that electrons, but what is types of electron? See, in any organic molecule, a molecule can be cyclic, chained, cyclic, molecule can be cyclic, okay, molecule can be conjugated, okay, molecule can be conjugated, molecule can be branched, okay, molecule can be like heterocycles, we have seen in our PGs, heterocycles. Okay, now can you tell me types of electrons in this? Okay, types of electron in this. Now see here, in this molecule, in this chain, how many types are there? Okay, now you just tell me how many types of electrons are there in this methane. Types of electrons. So I can say bonds. Just let me tell you by the concept of bonds. What are the bonds? Sigma bonds. Okay, four sigma bonds are there. Okay, here also sigma bonds. Here also sigma bonds. Here also sigma bonds. Here also sigma bond pi plus pi bond. Sigma bond plus pi bond. Okay, non-bonding. Only non-bonding and sigma bond. Now you see here. If you take this furan, this is what furan. Okay, this is what THF, tetrahydrofuran. This is the reduced form of furan. Okay, this is the reduced form of, this is universal, we can also say tetrahydrofuran, universal solvent, mostly available and very easily available, and it is a universal solvent, we can say tetrahyd, THF, we say this. Okay, in this R you see here lone pairs are there. Okay, lone pairs are there. Now you see sigma bonds are there, pi bonds are there, lone pairs are there. These all are kinds of, we also have seen this in resonance inductive effect. There we have seen in our chemical bonding. Okay, basics of chemical bonding, there we have seen. But that class, those who have not watched, you can watch that class, and then you will be having clear idea about that. So now first we categorize types of electrons. First we categorize types of electrons. First we categorize types of electrons. Now in this we have three types of electrons. Okay, three types of electrons. Now sigma electrons, pi electrons, and lone pair. Lone pair nothing but non-bonding electrons. How the sigma bond, pi bond, non-bonding orbitals are there, we have seen in the structures of and formation of bonding and non-orbital, bonding and non-bonding chemical bondings. That if at all you are new to this class, please watch that chemical bonding chapter also. So this is GOC in our general organic chemistry, that we have seen this also. Now you see what happens. Okay, now what happened? Our main aim is to generate, to break the molecule. If the molecule is this much, we have to make it half pieces. That is our aim. Okay, in mass spectroscopy, that is what our aim is. And when we are in that process, when we are in that process, these types of electrons plays an important role. Okay, what types of electrons plays an important role? How? Let us see one by one. Let us see one by one. Now first take, before this, let me explain you the concept of ionization potential or ionization energy that yesterday we have seen. The energy that is required to remove one electron from an outer shell or valency shell. This is what ionization energy. Let me tell you right here, ionization energy, IE. Write down here, IE. Write down the energy which is required to remove, the energy which is required to remove one electron from the outer shell, from the outer shell of a molecule here. See, I am saying here the molecule. Why? Okay, how in atom electrons are arranged in outer orbitals, okay, outer shells. In the same way, in molecule also our electrons are arranged in that way only. That is what we have studied in hybridization also. Okay, two intermixing of atomic orbitals forms molecular orbitals, the same number of, they are in same energy, that degeneracy that we all have seen. Okay, in GOC, hybrid, concept of hybridization, there we have seen. Okay, now this is what, now whenever the requirement of, first is this energy order. Okay, sigma bond, okay, sigma, pi and non bonding electron. This is what the ionization energy. Sigma bond is nothing but, for example, you see carbon, hydrogen. Okay, carbon and hydrogen formed one bond. Okay, carbon and hydrogen formed one bond. Now you tell me, what is the methane? This is methane, we know. This is methane. What is the configuration of this methane? 1s2. First, let me tell you what is this. Carbon. Carbon's atomic number is 6. Okay, atomic number is equal to number of electrons. Now 1s2, 2s2, 2p2. We know 1s2, 2s2, 2p2. Now you see here 1s2, 2s2. Now this is what? Orbits. Okay, these are orbits. Now you see, this is nucleus. Nucleus is nothing but, see, those who have a doubt, nucleus is that where neutrons are present. The total mass of neutrons is there. Okay, it's at the center of the atom. Okay, center of the atom. See, this is what? Nucleus. Now 1s2, 1 electron, 2 electron. Okay, 1 electron and 2 electron. Now 2s2. Okay, 1s2, 2s2 and 2p2. 4 electrons are there in this orbital. Okay, 4 electrons are there in this orbital. This, now let me tell you, now these electrons, now you see, this already we have seen in hybridization. Okay, already we have seen this in hybridization. 2p2. To eject this electron, okay, this electron to this, okay, you know, x, y, z, px, py, pz, that we are not dealing now here whole, but now you see here, those who have little idea, for making you aware this, that I am explaining here. Now you see, for this, now this electron transferred to this pz. Okay, pz. Now it is 4 hydrogens. 4 hydrogens are forming, and this is what sp3 hybridization that we have discussed. Now you see here, in this case, electron is very near to the nucleus. Electron is very near to the nucleus, and sp3. Okay, sp3 hybridization. When electron is very near to the this nucleus, it obviously it requires more energy to remove, or it won't easily give its electron to the other element, the other atom. So that is what the thing is. Now when it comes to pi, okay, how pi bonds be formed, in that orbital structure that you are remembering, and what are the non-bonding electrons. Okay, this is what all about electrons types and their ionization energies. So this is not here we are learning. Okay, our concept is something different here in mass spectrometry. Now this is for your understanding that I explained you. Now you see here, like this is ionization energy. Now ease of removing electrons, okay, ease of removing electrons, ease of removing ease of removing electrons, ease of removing electron, nothing but in which either from non-bonding or pi bonding or sigma or non-bonding or pi bond, in which your molecule, okay, which kind of electrons to be removed very easily. Okay, that is what, without less, we required less electron, okay, volts, okay, electron volts to remove the electrons first. Now non-bonding electrons are easily removable, then the pi bonding, and then the sigma bonding. Now then this is, okay, what is non-bonding, pi bonding and sigma bond electrons, just now I explained you. Okay, that is what, this is what ease of removal of electrons. Now we'll see, we have here so many cases, okay, we will be forming, and now we just see there, when there is a competition, okay, when there is a competition in removal of electrons and in formation of molecular ion, our aim is to form molecular ion here. What is our aim? Is to form molecular ion, as to as to break the molecule further and make into fragments. So that is what our aim here is. Okay, aim here. Now yesterday in general principles also we have seen that molecule M, okay, that electron beams, okay, electron beam, electron impact also you can say. Okay, then we have seen formation of molecular ion, and then for fragments, that hope that your M plus, M minus, M, okay, M radical, M plus radical, that you may be remembering that. Okay, now you see our aim is to form from molecule to molecular ion. In that process, the kind of molecule, and in that molecule what type of electrons are there, if which kind of electron gives easily, okay, which kind of electrons can be removed very easily. If you know this, you can analyze mass spectrometry very simple. Rest of the mass spectrometry becomes very simple if we have stronger the basics over here. Okay, which kind of chain, where to break, that we must have to know. If the compound is cyclic, where to break. If the compound is aromatic, where to break. Okay, if the compound conjugation is there, then where to break. Okay, this we must have to know in this mass spectrometry. This is what about this is. Now case 1, write down. Now case 1, write down case 1. Case 1. Okay, case 1, where all sigma bonds or sigma electrons, removal of sigma electrons, you just write removal of sigma electrons, from molecule, from the molecule. If the words or character, the alphabets are not visible, you can write by my voice. Okay, you can write by my voice. Now this is what removal of sigma electrons from the molecule. In this, if a molecule is alkane, okay, if a molecule is alkane, now carbon, now see, this is very important, carbon, hydrogens, okay, methane, this is organic compound, okay, methane. Now in this methane, the types of electrons first. Sigma bond, sigma electrons are there. How many sigma electrons are there? That yesterday we have seen. Okay, yesterday we have seen how many? Total 10. But here only 8 is representative. 8 is, why 8 is nothing but? Why 8 is 2 already there in s orbital. So that s orbital just have one s, one s2. That we are not going to bring here. They are not visible here. Now you just see. These are 2s2 and 2p4. Okay, 2s2, 2ps. Now you see, these are 4 electrons which are belonging to the hydrogens, and these are 4 electrons which are belonging to the carbon. Okay, these are belonging to the carbon. So how many? Now you see, this is what? Molecule. This is what? Molecule. This is molecule. To this molecule, if we give, what happens? If we give 7 to 15 electron volts of energy, then what happens now? This electron, the electron which is near to the carbon, now don't think that this electron is belonging to the carbon and this electron is belonging to the hydrogen. When you just have invested your money in any business with partner, then there is no such kind of things are left, like this is mine, this is your, this is all you, that is all belonging to you only now, you and your partner. So this our concept is comes. Okay, oneness concept is not there. R-ness concept is now. See, this both electrons are belonging to both hydrogens and carbon. Now, when carbon loses, now you see here, this see, since all the electrons are same. Okay, since there is no electronegative group, there is no attached to it, and there is no, it is not a bond change. Okay, it is not a chain or molecule, but it is just simply a methane. Now in this you see, when you are giving this energy, okay, this electron goes out. Removal of one electron from its outer shell, and that is leading to the formation of molecular ion that we have seen in our yesterday's class. Okay, in any molecule, if we remove one electron from its outer shell, that is the that is forming that molecular ion is. Now you see, carbon, we are not disturbing these hydrogens. Okay, we are not disturbing this hydrogen. Now you see, when carbon lost one electron, what charge it has to get? It has to get one positive charge. Okay, one positive charge it has to get. It is what? Carbocation. Okay, it is nothing but carbocation. And what is this? Hydrogen is there. Now hydrogen is having one radical. Nothing but we are not disturbing the electron of hydrogen. Now tell me, there is a bond in between carbon and hydrogen or not? Okay, there is. It is. Don't say that it is fragmented now. Okay, there is a bond. This one electron. Okay, this one electron moves from hydrogen to carbon to hydrogen. It always swings. It always swings from hydrogen orbitals to the carbon orbital to the hydrogen orbital. Bond is there. Okay, bond is there. Okay, this is that. Now you see, in this case, how many two electrons bonds are there? Two electrons bonds. Two centered, nothing but two nucleus. For your better understanding, I am explaining here. Two nucleus, two electron bonds are there in methane, in molecule. See here, two centered, nothing but carbon center, one center, two electrons. One center, one center. Now in this, you see, one electron, two electron. So four two centered, okay, two electron bonds are there. Bonds. Now you just see, this is very important. In NEET. Okay, NEET. Two centered. Okay, four two centered. Okay, four two centered two centered, two electron bonds are there. Okay, what? 4 two centered, two electron bonds are there in this. Now, in this, in molecular ion, how many two centered, two electron bonds are there? Here we have only three centered, okay, sorry, two centered, two electron bonds are there. Now, in this, now you see how many radical ions are there? How many radical atoms are there? One is two centered, one bond is two centered, one electron bond is there, two centered, one electron bond is there. This is why only I told you there is a one bond. Bond is still there between carbon and hydrogen. Okay, bond is still there between carbon and hydrogen. This is two centered, one electron bond is there. Okay, that is what existing still here. Okay, this is what our molecular ion. This is what our molecular ion. This is what our molecular ion. This is our molecule, and to this molecule we have given electron beam, electron impact. You can say electron impact. This molecule has gone under electron impact. Okay, and at that, how much energy that we have given? 7 to 15 electron volts, and that is led to the formation of molecular ion. I hope that you are cleared up to here. If not, you can raise doubt in the doubt index. Okay, first you have to write message like doubt corner. You can write your any kind of concerns in that WhatsApp. Okay, that is what is removal of sigma electrons from the molecule. Now just wait. Now CH3, CH2, CH3. Now, type of electrons are there. How many types of electrons are there? Only one type of electron are there here in this methane. Only one type of, that is carbon and hydrogen. Carbon and hydrogen sigma type of electrons are there. Okay, carbon and hydrogen sigma types of electrons are there. Electrons are there in methane. Now here in this, you see. Okay, how many types of electrons are there? Okay, how many types of electrons are there? Now in this case, we have two types of electrons. Two types of electrons. We have two types of electrons. They are now you see, one is carbon, and another is carbon and hydrogen. Bonds are there. Nothing but electrons. Okay, nothing but electrons. Okay, carbon and carbon hydrogen types of electrons are there in this molecule. So now in this kind of molecule, way to cleavage. Okay, way to make bond break. In this kind of molecule. So wait, let me check whether my video is functioning or not. Okay, in this kind of molecule, where to break? Always choose carbon bond to break. Now can you break for me? Carbon nothing but CH3, CH2. Okay, and now it is very important. Terminal carbon. Okay, terminal carbon bond is to be broken. Okay, what? Terminal carbon bond to be broken. CH2. Okay, now you see here, this cation and this CH3 radical. This is what actually is this. Now you can write this is equal to, in exam he will be giving us questions in this way only. CH3. Okay, CH4, like in this way only he is giving, or else he will give CH4 in this way he will be giving us. Okay, this is nothing but equal. Okay, this is nothing but either in this way or in this way or in this way. In exam most of the time he will give in this ways only. Okay, in this way only he will be giving us in bracket, but for our understanding it is better to write in this way molecule, where see in this way, in this molecule, in this type of example we don't know in which, between which carbon the bond is broken. Okay, in this we don't know in where the bond is broken, but if we write that in this two in this form, it is very easy for our understanding. So I explained you first this. Now you see here, this can we write in this form? Yes, obviously we can write. Obviously we can write. Now see, CH3 same, CH3, CH2, CH2 and CH3 here plus radical. Now can we write one more way? Can we write that in one more way? Now how many carbons are there? 1 2 3 4. Okay, C4, how many hydrogens? 3 5 3 5 10, CH 10, H 10. Now you see, this is what? H 10. So now we will be writing this into plus radical. So in exam either he will be giving us in this form or in this form, so we have to understand that in this form. Okay, so this can be understood by in this form and this can be understood by in this form, it is there. Now in this case, when you know where actually the cleavage is there, okay, when you know the rules how to remove electron and where to remove electron in the branch, okay, where to remove electron in the branch, then only you can be able to do this. Okay, this is that nothing but the basics. These are the basics in mass spectrometry, very important. If you know this, you can analyze this very nicely. Now this is one case. Okay, this is what? One case. Now come to the now we will be looking like in now in this is one chain. Now let us see when, okay, case number 2. Okay, in this only point number 2, when there is a chain, okay, when there is a chain, okay, when there is a chain is having branch, okay, when, write down, when carbon chain having branch, where to remove electrons. Okay, always remove electron where the connectivity is there, or nothing but bulky group is there. Okay, where the bulky group is there. Now you see here, CH3, CH2, CH3, CH2, 3, CH3, CH2, CH3. Now just imagine this iso 1 2 3 4 1 2 3 4 5 isopentane. You can say 1 2 3 comma 1 comma 3 comma isopentane, that you say this. We will be dealing in nomenclature of inorganic and organic molecule there in the class. Okay, don't worry about that, but this is a chain. Okay, this is a chain. Now in this always break, okay, always break that carbon, okay, always break that carbon in a chain, okay, in a chain that which is inside the chain, okay, which is inside the chain and where that carbon is, okay, where the carbon is. So we are breaking this. Okay, this hydrogen is not there actually, sorry. Now this we are breaking this. Okay, 7 to 15 electron volts. 7 to 15 electron volts. And that now can you write this? CH2 CH3, okay, CH2 CH3 CH3, okay, CH, everything remains same, there is no change in this, okay, CH3, okay, here positive charge, and now CH2 CH3. This is what our molecular ion is. Now, sir, why we are removing this carbon electron only? Okay, maybe you are asking this question. Now, when we remove this electron, this is become more unstable chain. Okay, nothing but a fragment. More unstable fragment. This is very, see, tertiary carbocations are very stable. This we know. Okay, stability of carbocations, especially in GOC, that we have seen, but still for you, tertiary types of primary, secondary, tertiary. Primary is less stable than the secondary, secondary is less stable than the tertiary. Nothing but we need here always that carbocation which must be unstable so that it can go under fragmentation very easily, as to analyze whole molecule in deep and more information can be extracted from the molecule, from the fragments. That is what our aim is here. Okay, in yesterday's class also we discussed this. What is our aim? To break the molecule, the compound into smaller pieces. How many types, how many more smaller pieces that we get, that much more information we get. If the information is more, our molecule can be studied in deep. Okay, our molecule can be studied in deep. This is what. So this is highly unstable. Highly unstable. You see, this radical ion is highly unstable. When this is highly unstable, this is very useful for the study of mass spectrometry. Okay, and that can easily generate fragments, and fragments only we want in this. Okay, maximum 80% of organic molecules, they agree with this. So this is what we know. Okay, this is, can you write in that rest of the true parts? Okay, rest of that, see, same, this is remains same. CH3, how in examination he will be asking us? CH2 CH3, okay, CH3, okay, CH3 CH2 CH3. He will be asking in this way. Okay, he will be asking in this way. He will ask in this way. R CH3 CH3 C CH2 CH2 3, like CH CH3 CH3 CH2 CH3. Okay, now here he will be asking either in this way also. This is equal to this and this is equal to this. Either, but for our better understanding we will be writing our compound in this way. Either if he will be giving in this either of the forms, you must have to convert for your basic understanding so that you can be easily breaking that in the examination. Okay, that is what. Okay, this is what, how to generate molecular ions from a branched chain. Okay, where to cut. Okay, where to cut. Our aim is to produce more unstable molecular ion. Okay, unstable or destabilized molecular ion. We don't want stable molecular ion. That yesterday we have seen in organic molecule, first stable molecule to be taken and that to be converted into unstable molecular ion. Okay, that to be converted into unstable molecular ion. That especially carbocations only. Mass spectrometry is only designed to study the carbocations, that we know. It can't study neutral, it can't study negative, it can't study radicals. It only studies cations. Now we have seen this. This is what. Next come to the when. This is that, hoping that you are understanding this and you can pass and note down this. I am very sorry. Now note down this. Note down this. Note down that. And note down this. Note down this. Now write down the points. 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 Like if molecule having, if molecule is having, if molecule if molecule is having, if molecule is having carbon carbon and carbon hydrogen bonds, carbon carbon and carbon hydrogen bonds, if molecule is having carbon carbon and carbon hydrogen bonds, if molecule is having carbon carbon and carbon hydrogen bonds, if molecule is having carbon carbon and carbon hydrogen bonds, always break carbon carbon bond only, carbon carbon bond only, carbon carbon bond only during electron impact, during electron impact, during electron impact. Now point number 2, in straight chain, in straight chain, in straight chain, removal of electron, removal of electron takes place, in straight chain, removal of electron takes place, in straight chain, removal of electron takes place, removal of electron takes place from terminal carbon carbon bond, terminal carbon carbon bond, terminal carbon carbon bond, terminal carbon carbon bond. That you write our first example. Okay, in branched chain, next point, in branched chain, in branched chain, in branched chain, removal of electrons, removal of electrons takes place from bulky substituted, bulky substituted carbon, bulky or bulky substituted carbon. That you write this example, this the example which is there on the board, you write that example, that you write now, that you write now. Now come to the, now come to the, now come, this is that. Now we'll be seeing in cycloalkanes, now we'll be seeing this in cycloalkanes. Okay, now we will be seeing this in cycloalkanes. Hope that you are understanding this. Now we will be seeing this in cycloalkanes. Now we will be seeing this in cycloalkanes. Cycloalkanes. Now organic molecules can't be in only in a chain. Okay, chain. Now cycloalkanes. Cycloalkane nothing but propane, butane, pentane, okay, pentane, hexane, okay, hexane, heptane, 7, okay, that octane, that you can write number, so much, so many number. In this case, types of electrons are present. Now just first our duty is to identify types of electrons. How many types of electrons are there? 2 types of electrons are there. One is one is hydrogen carbon electron and carbon carbon electron. 2 type of electron are there. And then what is our duty? We have to break carbon carbon first. Okay, carbon carbon electrons, we have to break carbon carbon. Now see this, how to be broken this. When we give 7 to 15 electron volts, 7 to 15 electron volts of electron volts energy, that it is be looking like in this way. Okay, it will be in this way. This is here positive and here radical. This is positive and this is radical. Now can you do this for me. Can you do this for me? Now here, this is what? Positive radical. Okay, positive radical. Now you see here, break this, break this, break this. Radical positive. Always positive charge should be given towards the chain. Okay, not away. Okay, towards the chain, as to make the molecule in more stable, and generating chain should be in more unstable. Okay, this. Now can you generate this? This is what? This is what? Positive radical. So these are. Okay, hope that you are understanding. Can you write in another form? In exam, how they may ask in us, for in exam, they may ask this in this way. Okay, they may ask in this way, positive radical. Okay, positive radical, nothing but see this. Okay, they may ask this, positive radical. They may ask this in this way, positive radical. They may ask in this way. Nothing but these are same. Okay, these are same. These are same. Positive, sorry, they may ask in this way. Okay, in this way. They may ask in this way, or they may also ask in this way, or they may ask in this way. Okay, or they may ask in this way, like they may ask. Nothing but you have to understand this. Okay, you have to understand. Okay, in exam either he will be asking us most of the time in this way or in this way, in this type, either in this form or in this form, but we have to change that into this form for our understanding. For and in your notebook, I appreciate that if you write in this way only for your better understanding, and you are also writing these are all forms also. This is what? Removal of, this case write down, removal of electron in cycloalkane. Okay, cycloalkane. Removal of electron in cycloalkane. Hope that you are understanding this. Hope that you are understanding this. This is what? This is what? We are little going, deep. Now from here your concepts are very important to be, okay, to understand. See, this is removal of cycloalkane. Or see, propane, butane, pentane, hexane. Okay, this is R. This is, okay, note down this. Pause your video for a while, for a second, and then note down that. Pause your video, then note down that. Pause your video and note down that. Now, hope that you have copied this. Hope that you have copied this. Now write down. Now see, if to any cycloalkane, is there any attached, groups are there, nothing but this benzene, methyl benzene, we say this methyl benzene. Okay, methyl benzene, understand? Now you see in this ethyl benzene, sorry, not benzene, ethane. You see this. Now in this case, where you have to produce, in this case you are breaking the carbon this, okay, the electron this, you are ejecting this electron, and now the charge is on this is very important to remember. The charge is on, now here positive and CH3 radical. Okay, now don't think that there is no bond between CH3 and this. This is our molecular ion, mostly unstable. If unstable is there, then more fragmentation, more information, deeper the study of molecule. This we know. Now here you see, this you have to break. This you have to break. Now this is formation again, cation radical. So this is, understanding, right? This nothing but here CH3. This is CH3. Okay, CH2. Hoping that you are understanding this skeleton structure. We say them skeleton structure. Okay, so this is what. Hope that you are understanding. Hope that you are understanding this. Now you see case number 2, when there is sigma and pi electrons are there in a molecule. Case number 2. Now competition between sigma and pi electrons. Case number 2. When write down, when, see, if at all you are writing, when I am writing on the board simultaneously, it would be very easy to you. So okay, when after completely listening that, if at all you are writing, that will be you are forgetting the concept in between also. Okay, as you wish, it is you make your own notes out of my words, so that will be very easy to remember longer time. So that when there are sigma and pi electrons are present in the molecule. When there are sigma and pi electrons present in the molecule. What? When there are sigma electron and pi electrons are present in the molecule. In this case, what we have to do is, now let us take example. CH3, CH double bond, CH3. Now see, types of electrons are there. Okay, types of electrons are there. CH, okay, CH3. Types of electrons are there. Now in this case, you see, pi electrons are there, sigma electrons are there. Okay, pi electrons are there, sigma electrons are there. In this case, these hydrogens, now you see, hydrogen, okay, this is hydrogen, and these are hydrogens. Okay, these are our hydrogens. Now in this case, you see, this is pi bond. Okay, this is pi bond. What we have discussed, ease of removal of electrons. First from the non-bonding, from the pi, and then sigma. So we studied sigma. Now come to the pi. Okay, now come to the pi. Sigma, carbon is there, carbon hydrogen is there, carbon sigma is there, carbon pi is there, carbon sigma is there. So there are how many kinds of electrons? 3 kinds of electrons now in this. Carbon hydrogen, okay, carbon hydrogen sigma, okay, carbon hydrogen sigma, carbon sigma, okay, carbon sigma. Now carbon pi, okay, carbon pi electrons. This is important. 3 types. Okay, 3 types. Now you tell me where I have to break, where I have to make carbocation, where there is a cleavage, where there is a lysis, where there is a breakage. Now always In this case, always remove, always break that place, this, okay, where the pi bond is there. Okay, now can you do this? Can you break this? CH3, okay, CH3, CH, okay, positive. See, one bond is there. Okay, we are only concerned with the pi bond only here. Okay, we are breaking pi bond. Carbon. Okay, now hydrogen is there here. Okay, carbon hydrogen is there. CH3. This is what our molecular ion is. So in this way he can be giving us. Okay, in this way he can be giving. In this way, in one more way, CH3, CH double bond, CH3. In this way he will also be giving us. Okay, in this way also he will be giving us. Can you tell me one more way? CH3, CH double bond, CH3. Okay, in this way. Okay, in this positive, negative. So ultimately he is not giving us here, where he will be giving only in this form, either in this form. He is not mentioning where exactly cleavage have happened. We have to understand here the cleavage is. We have to bring this form into this form for our understanding in the exam. If you don't know these basics, you can't be attempting any question in the CSIR. So this is what. Now let us take some more example. And understand. Now you see, can you tell me some other examples? Now you see, benzene. In benzene also double bonds are there. Same way, in benzene also double bonds are there. Okay. 12 to, see here I am not writing here always, like 7 to 15 electron volts. Always you have to, nothing but electron impact. Nothing but this molecule have gone under electron impact at the 7 to 15 electron volts, and that is generated molecular ion, and that molecular ion can be in these three forms. These two forms can be given in exam, and this for our understanding. Okay, now this is also having pi bonds. Now can you break for me? Now break this in this way. Break any pi bond. All are same electrons. Nothing but this is also. See, sp2 hybridized. We know sp2 hybridized are nothing but all same. Now you just listen. In this case, you can break this here positive, here radical. Okay. Now rest remains in this way. He may be giving us in this way, like benzene positive radical. Okay, or he may also giving us in this way, benzene in this way. Okay, in this way also he may be giving us. Okay, in exam most of the time he will be giving us in this form. We have to understand in this form. Okay, in this form, when you know the basics. So this is what, hope that you are understanding well. So note down this. Okay, note down this. Quickly note down. Now can you tell me, if acetylene is given, acetylene is, what is acetylene is? Okay, acetylene, nothing but you just see CH, C triple bond, C, CH. Okay, CH, nothing but CH3. Okay, CH3 triple bond, easy. This is what acetylene is. Now in this case, you see, now where to break? Now this is very important. Where to break? This is SP. Okay, SP, and this is what? SP3, and this carbon is SP2. This is, now you understand. Now in this case, okay, first our rule is what? First we have to look, it is a branched, okay, it is a branched. If it is a branched, then we must have to break that bond which is terminal to the chain. Okay, now when it comes to the pi bond and sigma bond competition, and if the bond is there, wait for 1 minute. I am not getting, my video is functioning. Okay, if if the bond is there, if the carbon is sp hybridized, nothing but it is very near to the nucleus. Okay, very near to, electron is very near to the nucleus, it can't give very easily, so it is more stable, so it can't be useful for us. So we are not breaking here. In this case we have to break this bond. Okay, we have to break this bond. Okay, we are breaking this bond. Now in that case, can you generate CH3? Okay, CH3, C, okay, triple bond, okay, C triple bond, C, CH3, C triple bond, C carbocation, and CH3 radical. So this is what our molecular ion is. These all are what is molecular ions. These all are molecular ions. Okay, molecular ions are further cleavaged. Okay, further go under fragmentation as to form pieces. Pieces nothing but fragments, so that we study better way. So this is what you are understand. Can you Can you tell me benzene? Benzene we have studied in. You can take any molecule that of your wish when you know the proper concept. Benzene, that this we have seen benzene. This is pseudo pi bond. This is exactly not as it is there. It is like in this p orbital, empty p orbitals are forming. So this is not exactly bond is there actually in that benzene. But can you form this now? Can you do this for me? Okay, nothing but you are breaking over here. Okay, you are not breaking over here, you are breaking here or here. So that is what the concept is. Hope that you are understanding this well. Now note down this acetylene example also. Note down that acetylene example. Note down that acetylene example. Note down that acetylene example. Acetylene example. Now when there is sp3 and sp2 and sp hydrogens are there. Now can you write down this? In this case, CH3 CH double bond CH C triple bond, okay, C triple bond C CH2 CH3. Now see here, how many types are there? sp2, okay, 1 2 3 4. No, this is not in this way. 2 1 H. Okay, sp2 hybridized. Okay, sp2 hybridized. This is also sp2 hybridized. Okay, sp hybridized, sp hybridized, sp3 hybridized, sp3 hybridized. We know this hybridization. Okay, we are not going that sp3 hybridization, but our focus is on sp2, sp2. This is also sp2. Okay, and sp. Okay, either I have to break here sp carbon or sp2 carbon. Here just now I told you here sp, here it is very near to the nucleus that we cannot break there. So as to do that, we must have to cleavage here you have to break, and here nothing but our molecular formation is carbocation, carbon anion. Okay, and later you can write in this way. Okay, in this way. Okay, in this way, plus charge. This is one more, and now either he will be giving us in this way, okay, that is what our answer is. So molecular ion is, okay, this one is our molecular ion. Hope that you are understanding this. Okay, hope that you are understanding this. Now let us go for the next. You write down this expanded form now. You write down that expanded form. of that. Hope that you are understanding. If at all you are not understanding that, sir, I haven't understood, you have to WhatsApp me. Okay, WhatsApp me. Understood that. Now when molecule is having, now case number 3. So write down here one point. Write down here one point. When molecule is having, when molecule is having when molecule is having sigma and pi electrons, sigma and pi electrons, when molecule is having sigma and pi electrons, when molecule is having sigma and pi electrons, always break at pi bond. Okay, pi electrons always break pi electrons, always break pi electrons. When, now write down one more point. Write down one more point. When there is a competition in breakage, there is a competition in breakage, there is a competition in breakage between sigma bond and pi bond, sigma bond and pi bond, and sigma bond is involved in sp hybridization, sigma bond is involved in sp hybridization, sigma bond is involved in sp hybridization. Okay, okay, and pi bond is involved in sp2 hybridization, sp2 hybridization. There is always sp2 hybridized position of carbon carbon chain. Okay, carbon carbon bond is made, made to break, made to break, made to break. Okay, made to break. That is what. Now case number 3. Okay, now case number 3. When, now case number 3 will be doing, we will be doing this now, case number 3. Now you see Nana here, when removal of, 3, removal of electron, removal of electron, in a molecule, where sigma bond, sigma bond and non bond and pi non bonding electrons are there. When there is two types of electrons, one is sigma electron and one is non bonding electron. Non bonding nothing but lone pairs of electrons, non bonding is nothing but lone pairs of electrons. Now you see CH3Cl, methyl chloride. Okay, this is what methyl chloride. Now in this, chlorine is having what? 3 pairs of lone pair electrons, 3 pairs of lone pair electrons. Now it have gone under 7 to 15 electron volts. Okay, we have provided to electron impact, and now this one pi bond, this one pi bond ejaculates, nothing but emits out, removed. And then there is a formation of molecular ion, this. There is a formation of molecular ion, this. Positive radical, 2 pi, pi electrons are there. This is what our molecular ion is. This is what our molecular ion is. Now CH3, CH2, Br. Br. Now you see bromine, same, remove one electron. Nothing but again same. You are writing CH3, CH2, Br, bromine, bromine, pi, and this radical. This is what our molecular ion. This is also molecular ion, which is more unstable. okay, which is more unstable. It further goes into fragmentation, as let us understand that. Now, this is, hope that you are understanding this. Now in cyclic, okay, now in cyclic, now you see chlorine, okay, same, that you are understanding this, okay, same, remove this one, okay, then chlorine, positive radical pi bond, sorry, lone pairs, same that you are doing for so many, whatever that molecule that, see, after explanation, after explaining these topics, basics, I will be conducting all the exams, test series, okay, so there you have to apply all this concept, okay, I will be providing you that test series, this one. In this, now you tell me CH3, CH2, OH, ethyl alcohol. In this first lone pair, oxygen is having lone pair. Now can you generate? Okay, CH3, CH2, positive and radical lone pair and hydrogen. That's it. This is what our generation of molecular ion is. Now you can take ethers, epoxides, okay, CH3, CH2, okay, O, CH2, CH3. You can take any number of, okay, you can take any number when you know this. CH3, CH2, okay, O, radical positive, and then CH3, this, that you can write your own. So can you, hope that you are understanding this. Now instead of this, he may be giving us in this way, that you are understanding, hope that you write in every form, okay, positive and radical, okay, in this way, or he may be giving us in this way also, okay, in this way also he will be giving three forms, okay, three forms, two, most of the time rest of the two forms are asked in the exam, and this, and if the he is asking in that way, we have to convert in this way, that you are understanding this, okay. So this is what all about removal of electron in a molecular molecule where sigma bond and non-bonding electrons are there, okay, non-bonding electrons are there. So now let us analyze how many types of electrons that we have seen, okay, types of electrons, way to break the bond, okay, way to break the bond that we have seen. In a molecule, okay, in a molecule where all sigma bonds are there, in a molecule where sigma bonds and pi bonds are there, where the molecule sigma bonds and non-pair bonds are, lone pairs are there. So this we have seen in a chain and a cyclo, chains, okay, chains and cycloalkanes, that we have seen. This we have seen again in chain, and here branched also we have seen, okay, chain, and also in aromatic compounds like benzene we have taken, okay, like that. Now in this we have taken chain, in chain alcohols, bromines, chlorobromine. So that you now hope that you are understand. This is what this. Now in this, just now I told you, this is molecular ion. Remove this positive, negative, radical. This Now so this also we have seen. Now let us go for the another possibility. Sigma bond, non-pi bond, sigma bond, pi bond, and non-bonding electrons are there in a compounds. Okay, what is sigma bond, pi bond, and non-bond electrons are? Three types of bonds are there in molecule. So where first cleavage is taking place. So this is our case now. Removal of electron in a molecule. Now write down case number 2. Number 4. Okay, removal of electrons in a molecule, removal of electrons in a molecule where all sigma electrons, pi electrons, and non-bonding electrons are present. So this is case. Now let us take some examples. Benzene. Okay, benzene. This is what first case our only sigma bonds are there, sigma electrons are there. In this case we have to take, in that case we have broken the bonds here, this, okay, radical. So this is what, and we generated molecular ions. Now benzene type 2, where sigma bonds and pi bonds are, sigma electrons and pi electrons are there. We have broken in any way, okay, and we formed this molecular ions. Okay, we formed this molecular ions. Now you see phenol. Now I am taking phenol. Okay, now I am taking phenol. This is what phenol is. Okay, if we add, okay, OH group to the benzene, then this is what phenol is. Okay, phenol. To phenol. Okay, phenol. How many types of electrons are there? Carbon carbon, sigma bond is there, pi bond is there, lone pairs of electrons are also there. Nothing but lone pairs, nothing but non-bonding electrons are there. When non-bonding electrons are there, first our ease of removal, that you are remembering, first non-bonding, then pi bonding, and then sigma bonding. First here non-bonding. So electron from oxygen it ejects. Okay, it removed. Okay, now this we know. When electron is removed over here, in this case, now here oxygen is having one positive and one radical, and this hydrogen is in this way, one electron pair, and this remains same. This is what our molecular ion. This is what our molecular ion. Now if I write chlorobenzene, okay, chlorobenzene, this is what chlorobenzene is. Chlorine is also having same. Now remove this one electron impact. Okay, electron impact, and energy is 7 to 15 electron volts. Okay, same energy is 7 to 15 electron volts, same. Now you write chlorine positive radical 2 lone pair of electrons. Okay, initially how many lone pairs of electrons are there? 3 lone pairs of electrons are there. When it comes to here, how many pairs are there? 2 lone pairs are there, and one free radical also there. Okay, one free radical also there in chlorobenzene. This is what, where you have come across this 3 types. Now let us go for some examples. More examples. Hope that you understand this and write that. Okay, take your 5 minutes, your 3 minutes time, your own, and prepare your own notes. Okay, prepare your own notes. I am saying that prepare your own notes. Prepare your own notes. Take your time. Prepare your own notes. Prepare your own notes and write down now some examples, and try yourself, and which type that are you have to go with yourself. Now try this. What is this? Furan, tetrahydrofuran, I told you, and this also we discussed in our GOC also. Okay, this is what? This is furan, pyrrole. Okay, this is what? Pyrrole. This is, try this. Okay, try yourself. tetrahydrofuran and this is furan. Okay, this is furan and this is tetrahydrofuran. THF. Try this. If you know well, try this also. Okay, try this also. Try this also. Pyridine. Try this. Pyridine. Right, this. Now in this case, what happens, lone pairs are, you have to imagine, there are lone pairs are there, you have to imagine, and there one lone pair goes and there is a formation of this kind of, okay, there is a formation of positive lone radical and then hydrogen. So in the same way here also, in the same way pyridine also, okay, pyridine also. So hope that you are understanding this. Now try for this. Now aniline, if we add this NH2, aniline, this is what aniline is. Amine, we say amine, primary amine, secondary amine, tertiary amine, all you have to try yourself. Okay, all you have to, primary amine nothing but CH2 NH2 hydrogens are there. Okay, primary amine. Here you have to imagine the lone pairs and remove this lone pair and frame form plus and radical, and that is what your molecular ion is. Now CH3 NH, okay, CH3 secondary amine, secondary amine, primary, okay, secondary, and CH3 NH, no NH, CH3, okay, CH3. This is tertiary. Okay, that is tertiary. Hope that you are understanding and you are also doing this all. You are trying your own. This all you have to try your own. This all you have to try your own. Try it now. Okay, try it now. 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 Now I am explaining here now one more case. Now you see in this case, my question come in this area. Okay. Now cyanobenzene also you try. Okay, you try cyanobenzene. You try C triple bond N. Now you try nothing but see, this is only okay pi bond. Nitrogen is having lone pairs, so that you remove, and that is cyanobenzene. Okay, try this. And now see here, in this case now you see like CH3 C double bond O, okay, OH. Now you see sir, here we have 2 pi electrons, okay, lone pairs, okay, lone pair of electrons. Here also lone pair of electrons. Lone pairs of electrons we have, lone pairs of electrons we have. Which lone pair of electron goes? Okay, which lone pair of electron goes? Which lone pair of electron forms molecular ion? Always in this kind of always form, there is always form which is conjugated. Okay, which is conjugated, nothing but which is attached to the hydrogen and that is having double bond. Always break the double bonded electrons. Now you see pi is there and non-bonding is there. Here sigma is there and non-bonding is there. So you see pi, see when non-bonding, pi and sigma. Okay, here this is our order. This is our order. In this case we have one is non-bonding and pi bond. Okay, in the next case we have is non-bonding and sigma bond. Sigma bond is electrons are very near to the s orbital. Okay, in s orbital are very near to the nucleus. We can't touch them, we can't remove them as simple as, so that this choice is best. Okay, this choice is best and you are removing this. Now one more case, CH3 acetate, C double bond O minus. Now in this case, minus is nothing but how many electrons are there? Electron pairs are there. Obviously 3 electron pairs. Minus is nothing but it lost one it lost one hydrogen. Okay, it lost one hydrogen. And now you see, instead of minus charge, I am writing 1, 2, 3, 4, 5, 6. So how many total? How many electron pairs are there in this? How many electron pairs? 5 electron pairs are there. Okay, in this how many electron pairs are there? Only 4 electron pairs are there. In this 5 electron pairs are there. And this electron pair is this electron. Okay, now you see, this electron, one electron is not belonging to this hydrogen. One electron is not belonging to this hydrogen. This oxygen, this electron is of hydrogens. Since hydrogen is left over, this electron is on this oxygen, and that now the formation of nuclear molecular ion is in this way. Okay, CH3, C double bond O, C radical double bond 2 pairs. See, this is what our molecular ion. This is what magic of this. Okay, this is our molecular ion. Hope that you are understanding. 7 to 15 electron volts. Everywhere you have to write 7 to 15 electron volts. Here 7 to 15 electron volts. Here 7 to 15 electron volts. Here 7 to 15. Here 7 to 15. Here 7 to 15. Everywhere, and then you do by yourself. Okay, you do by yourself. This is, try this one more. Okay, try this one more. Try that one more. Try that one more now, fast, quick. We have to wind up this class. Okay, try this one more. Try this your own. Try this your own. Now one more case, let us see. In this case only. Now in this case, try your own. Now in this type, now you see, nitrogen, not nitrogen, carbon double bond. Now in this case, now you see which two undergo. Okay, how many pairs of electrons are there? One lone pairs of electrons. 1, 2, 3, 4. 1, 2, 1, 2, 4. 4 electron pairs are there. Now, when this hydrogen goes, there is a formation of molecular ion in this way. Okay, that is a formation of molecular ion. See, the concept is this. Okay, see, the concept is this. This is the concept. Now, now you can try for this also. Now you can try for this. Okay, now you can try for this. Try for this. And further 2 for 5 minutes class is there. Okay, 5 minutes class is there. Try that quickly. I said try that quickly. Now you see, if benzene, nitrogen, double bond, oxygen minus plus. Okay, now in this case, now this is a magic. Now maybe you are surprising, but it is not. Now you see here, 7 to 15 electron volts. 7 to 15 electron volts. In this case, how many electron pairs are there? Okay, how many electron pairs of non-bonding electrons are there, or how many electron pairs are there? One negative charge is nothing but 2 electrons we must have to imagine. Okay, 2 electrons we must have to imagine. One pair, 1 2 3 4, 1 2 3 pairs. Okay, 1 2 1 2. These are the pairs of electrons. These are the pairs of electrons. In this case, always you remove this electron. Okay, this electron. Now, and our molecular ion is this. Our molecular ion is this is our molecular ion. So positive charge always stays there. No problem, no worries with the positive charge. Okay, and here is also positive radical. Here it is radical. Hope that you are understanding this. Okay, hope that you are understanding this. Here this nothing but this. In this, now tell me, now why this minus charge came? When it lost one electron. Okay, when it lost electron, nothing but hydrogen provided that one electron to it. Okay, so from there, when it lost, and this is what the molecular ion that we are getting. Molecular ion can also be write this in this way, like minus, like a radical, and that another form also. You just try your own. Now tell me, sodium. Now tell me, if a sodium is belonging to first year group element. Okay, sodium is belonging to first year group element. If it is given 7 to 15 electron volts, then what we will get? Sodium Na plus. Okay, Na plus, nothing but it is sodium cation. Sodium cation is nothing but our molecular ion. Sodium molecular ion. Now calcium. Okay, to calcium plus, if we give, okay, calcium plus. Okay, see here why I am writing calcium plus 2. Okay, because it is belonging to the second year group element. So in this, if we give calcium plus 2, okay, plus 2, what is carbocation? Plus. Okay, aluminium. Okay, aluminium plus 2. Okay, aluminium plus 2, aluminium plus 3. Okay, aluminium plus 3. So these are our, see, plus 3 plus 2. Okay, plus 3 plus 2, nothing but removal of any. So don't always think that only whenever you are seeing that molecular ion is in positive cation. This is also can be done, aluminium cation. So these are also types of molecular ions. These are also types of molecular ions. Okay, these are also types of molecular ions. Hope that you are understanding this. Okay, hope that you are understanding this. Okay, hope that you are understanding this. Okay, actually I have to write in this way. The arrow should be in this side, right? Arrow should this side. Okay, arrow should this side. So from 2 to 3 we are framing. Okay, we have to see, if the plus charge is increasing, nothing but what does it mean? If plus charge is increasing, nothing but it means that it losing its electrons from its shells. Okay, so that in that case, everywhere you have to write this 7 to 15. Now last case we will be looking, and this winding up. Okay, in this case, now you see, when there is like CH3 no, not this case. Okay, no, not this. Fine, up to here you complete. Okay, up to here, and tomorrow in our class we will be seeing there some kinds of different molecules that we are seeing tomorrow, and their stability order that we are seeing tomorrow. Their stability we will be seeing in our tomorrow's class. Their stability we are seeing in tomorrow's class. their stability we are seeing in tomorrow's class. Thank you for watching this video. But you have to do those examples by your own. If you have any doubt, you can text me. Okay, if you have any doubt, you can text me. Thank you.